Already recorded. Alright, so video question 4. The circuit shown represents a battery with unknown voltage source and the internal resistance. An amp meter, the circle with an A right here, measures the current in the circuit as shown and can be treated as a circuit element with zero resistance. When the switch is open, as we see here, the amp meter will measure 0.369 amps. And then when the switch is closed, so when the switch closes here, the amp meter will measure 0.35 amps. So they're asking what the voltage source, and the internal resistance of the battery. So what we're going to want to do here initially, we just want to label some stuff. So we're going to want to label the dV here in the battery because the battery has a voltage difference created across of it. This is the internal resistance. They're just showing it as an external resistor, but this is the internal resistance of the battery, like what we're trying to find. So, and then we're going to go ahead and make 2 loops. So I made my first loop around here, labeled it I1 for the first current, and then I2 coming down here into this resistor right here. And then for the loop 2, it's the closed loop when it is closed, so this part of the loop. So we have I3 coming out of it, coming down into this resistor here. So we also have our junction here, so we have I1 coming into the junction, and then I2 and I3 leaving. So we're going to go into our loop equations here. Since we have 2 unknowns, we want to make at least 2 equations. So first off, we're going to start when the loop is open. So we're going to do loop 1 with the open switch. We know that the amp meter is reading 0.369 amps, and we know it's going to be a negative because the current is going in the same direction as the resistance. So we're going to multiply that by our internal. And then we have also the 0.369 amps times the 30 ohms, which is coming down here because we know that at this point the amp meter is reading 0.369 amps. So that's going to be going down here and since it's going the same direction as the resistor, it's also a negative number. And then we have the dV, and so this is always measured from V final minus V initial. So V final here is positive. It's going to be more than V initial, so we're going to have a positive delta V. And then we have when the switch is open for loop 2, there's going to be no current running through it because when this is open, nothing is going to be running through it. It's only going to be running through loop 1. So it's just going to be 0 with an open switch. So then we also want to account for when the switch is closed. So loop 1, when the switch is closed, we don't know what I1 is because we cannot tell at that time what the current is because we only know what it is at the amp meter. So we're going to have negative I1 multiplied by the internal resistance of the battery, which is still negative because the current is still flowing that way based on our loop. And then we're going to have 0.35 amps times the 30 ohms because that's, as stated, that's what we know what the current is at that time when the switch is closed. And then we're also going to have another positive delta V. So this is when it switches up because loop 2 is now activated because it's the switch is closed. So we do not know, it states nowhere what I3 is. So it's also going in the same direction as the resistor is, like the current is going in the same direction. So it's going to be negative I3 multiplied by the 42 ohms. And then we know what I2 is, and it's going to be positive in this situation because we have I2 going down, but our loop is going up. So it's going to be a positive 0.35 amps times that 30 ohms right there. Just write that in. Okay, so that's going to equal 0. So we're going to do here, since our only unknown is I3, we're going to solve for I3. We get I3 equals 0.25 amps. And now what we're going to want to use, now that we know this, we're going to want to utilize our junction equation. So for our junction equation, just like we said, we have I1 coming into it, I2 and I3 leaving it. So we know that I1 is equal to I2 plus I3. So when the switch is closed, like again, we know what the current is in I2. It's 0.35 amps. We just solved for I3 in the previous equation. So now we get what I1 is. And then, so from the close switch equation of loop 1, which we established earlier. This is it rewritten right here. We now know what I1 is, so we can solve for it in terms of delta V. Okay, since we have two equations with two unknowns here, we solve for this equation. We plug in with what we knew. Solve for this equation, delta V, and then we're gonna plug this delta V into the open switch from loop 1, stated earlier. So we're just gonna plug that. This is it rewritten right here. We're going to plug this value in for the delta V, and then we're just going to go ahead and solve for the internal resistance of the battery, and that internal resistance of the battery is going to be 2.48 ohms. And then again, since we solved for the resistance, we're going to go ahead and use this equation up here to solve for the voltage source. So this is just rewritten the equation that we solved for, delta V. Plug in our internal, which we know, and then you're going to get the voltage source from the battery to be 11.98 volts. I hope you found this helpful, and thank you for watching.